chia sẻ màn hình. Gọi là mọi người có thể nhìn thấy cái màn hình của mình đang share. Công ty VNco là một công ty về cổ phần tư vấn đầu tư và xây dựng. Trụ sở của chúng tôi là ở khu vực Hà Nội, thành lập từ năm 2007. Giám đốc của chúng tôi là một kiến trúc sư khá nổi tiếng trong lĩnh vực kiến trúc và công trình xanh, đấy là anh Nguyễn Trung Kiên. Thì website của công ty thì có ở trên màn hình, đấy là vlenco.vn. Mọi người có thể tìm hiểu thêm thông tin về công ty ở đấy ạ. Về công việc chính của công ty thì chúng tôi chứng nhận là cung cấp cái dịch vụ tư vấn chứng nhận công trình xanh, tư vấn về các giải pháp mà công trình hiệu năng cao hướng tới là Near Zero Energy Building, Net Zero Energy Building. Giới thiệu qua thôi, bởi vì là cái buổi ngày hôm nay xin phép là để dành cho phần trình bày của chính hãng. Mọi người thể thấy là ở trên màn hình thì là anh Nguyễn Trung Kiên là giám đốc của công ty, cũng là một người khá là có tiếng ở trong lĩnh vực công trình xanh. Anh đang là một trong những thành viên sáng lập cho tổ chức PGBC, tham gia vào rất nhiều các hoạt động trong về công trình xanh của Việt Nam. Trong các dự án công trình xanh của công ty đã thực hiện thì mọi người có thể thấy có những công trình của Capital House, của Sao Thái Dương và nhiều tổ chức khác nữa. Chúng tôi có rất là nhiều đối tác ở trong cái lĩnh vực này, nổi tiếng như Herim, như Obayashi, các cái đơn vị khác. Đây là một số công trình mà phía công ty đã tư vấn cho chủ đầu tư và áp dụng thành công và đã đạt được các chứng chỉ. Mọi người có thể thấy đây là tòa nhà Star ở khu vực Liễu Giai, Hà Nội, đây cũng vừa mới được chứng chỉ xong. Hay là Trung tâm Lưu ký chứng khoán Hà Nội ở đường Hoàng Quốc Việt, đây cũng là một công trình thành công của công ty. Ngoài ra thì còn có rất là nhiều các cái công trình khác. Để tiết kiệm thời gian cho buổi họp ngày hôm nay thì tôi xin phép sẽ chỉ show lên trên màn hình. Mọi người có thể tìm hiểu thêm thông tin ở website của công ty là vlenco.vn. Ngoài ra, bên cạnh cái lĩnh vực về công trình xanh thì Vlenco còn có một mảng công việc khác liên quan đến phần là đại lý của một số phần mềm và đại lý phân phối và đào tạo trong một số phần mềm. Nổi bật trong đấy thì có các phần mềm của hãng Grasshopper như là Archicad, BIM-VN và BIM-Cloud cho lĩnh vực công trình xanh và tính toán năng lượng cho công trình. Thì có các phần mềm như Design Builder hay là Energy Plus. Phía công ty vừa phân phối vừa có các các chương trình đào tạo cho các cái phần mềm này. Xin phép đi rất là nhanh qua cái lĩnh vực này thôi. Và ngoài ra thì công ty cũng có các cái khóa đào tạo liên quan đến các phần mềm như Archicad, liên quan đến phần mềm như Design Builder. Thông tin chi tiết cũng vui lòng xin xem ở trên trang web của công ty là vlenco.vn. Ngoài ra thì chúng tôi cũng có rất là nhiều các hoạt động hợp tác đào tạo và nghiên cứu khoa học. Trong đấy có các đối tác mà mọi người có thể thấy trên màn hình, ví dụ như là trường đại học xây dựng, trường đại học Bách khoa Thành phố Hồ Chí Minh hay là trường đại học Việt Pháp ở Hà Nội. Nói sơ bộ về công ty như vậy, để giới thiệu là chúng tôi có làm trong lĩnh vực công trình xanh, có làm trong lĩnh vực tính toán năng lượng hiệu quả và cả trong lĩnh vực về BIM cũng như các phần mềm về BIM tool như là Archicad. Chính vì vậy ngày hôm nay chúng tôi rất là vinh dự đã được Ban chỉ đạo BIM quốc gia cho phép tổ chức buổi hội thảo ngày hôm nay, hướng tới cái yếu tố là công trình sử dụng các công cụ của BIM để tính toán các tính năng của BIM hay là chúng ta vẫn hay gọi tắt là BIM đấy ạ. Thế không để mất nhiều thời gian của buổi ngày hôm nay nữa thì tôi xin phép sẽ nhường lời cho anh Sandor, chuyên gia của Grasshopper, về các yếu tố mà tôi vừa kể trên. Hi Sandor.
Hey, hello.
Yeah, I've just finished a quick introduction of Vlenco's and the reason why we're here. You can take it from here.
Sure.
All the best.
Let me share my screen. Okay, do you see the presentation now?
Yes, I can see your presentation online.
Okay, so let's get started then. So hello everyone, my name is Sandor. So I guess I was briefly introduced, but Basically, I'm a BIM consultant in Asia, in Southeast Asia, with Graphisoft. And today I would like to show you our green building design solution, what Graphisoft can offer in this field. So, but before we do that, I would like to show you what are the industry trends, or basically what are the challenges, what is as an incentive for us to do this green building design. Why should we even care? What are the challenges? What, in general, why is it important, and what is our workflow within our BIM solution? Okay, so let's take a look at this. So first of all, the incentives. So why should we do this? Well, sometimes it's not because we want to do it, but it's just required. So if it might be required by the owner, because the owner wants to have their building certified, the project certified energy certification. On the other hand, it's also possible that maybe it's not required by the owner, but it's required by a local building code. So they require us to fulfill a minimum energy performance, and then we have to prove that our building is capable to do that. Obviously, besides that, as a business decision, we can choose to do this, and with this we can impress the client. We can show that we are doing an energy conscious design, and basically this is eventually going to improve the project, and it is going to improve the client's satisfaction. Sorry, could you please help to mute the participants? I'm echoing.
Okay, anh Bình ơi, anh Bình có thể mute những cái.
Okay. Thank you. Okay, so then the other thing could be to have a strong stand against the engineer. So basically, we can, when we talk with the engineer, we can have an argument why we chose that particular design that we chose. So we can use this as a base for discussion with the engineer, those results that we get from our energy conscious design or the energy performance review that we conducted. And since we are already talking about what we did, it means that we made design decisions. So we are not just designing because of aesthetics or because of functionality of the space itself, but basically we made an energy conscious design decision. So there is a reason why we use a particular structure. There's a reason why we use a particular shading or window size, for example. And we can also compare these different results, and based on the different results, we can choose which one will fit best in terms of the whole project. And actually, if we all consider all these things that I just mentioned, all these incentives, if we do energy conscious design based on any of these, then right away we already have a competitive advantage compared to all those other companies who don't do this, right? But obviously it's not that simple because there are some deterrents. So why we wouldn't want to do this, right? So sometimes we think that this building physics, energy related design is too complex. Eventually, I myself, I'm an architect by profession. So I know the basics of building physics, but not all the small details, right? So, and probably that's true for all the architects, that they are more focused on the design or on those architectural tasks which are related to the design, project management, but not the building physics, right? So we can say also that, why would I do this? This is for an engineer. So I'm just an architect. This is too complex. BIM is complex. It's not for me. And anyways, I would probably need some additional software as well. So I should learn something new as well. This is just not for me, right? So obviously we have to face this. It's not just the full go, but there's also a stopping motion as well. But let me try to convince you still. So why should we do this? If you look at the energy use of the different sectors, then you can see transportation, industry, and buildings. Basically, buildings take the majority of the energy use, and even according to the cover of the National Geographic magazine, you can see energy saving starts at home. Obviously, this takes it down to the level of the individual person, but it's true for the industry as well. And actually, this has been there for quite some time. So I think this issue was coming out in 2008, 2009, March. I can't see exactly, but it's more than 10 years old. So we already identified this quite some time ago. Okay, so if you look at the building's life cycle, there are different phases, and basically in each and every phase, we have an impact on the environment. So whenever it comes to projects, especially when it comes to software vendors, we always try to promote something, or well, actually, that's the thing. We not always try to promote it, but what is the perception is that we always focus on the design phase. When like how to model a building, that's always about the design phase. But that's actually not the way to go. We have to look at the whole life cycle of the building because the environmental impact is there in every phase. So even when you get the materials, when you purchase the materials, how the materials are produced, how they are, let's say, the mining of the material, then the processing of the material, then the construction itself is impacting the environment. But actually the biggest environment is through the operation. So it's very important to come up with a design that will affect the operation in a good way. And even after the operation, actually, we still have environmental impact. If you do a renovation of your building project, or if you demolish it, these all have impacts, right? So let's just take a look at this diagram, like how, let's just visualize this. Okay, so if you look at the cost, the primary energy, and the carbon dioxide emission, then you can see that even at the investigation and the design phase, there are some small peaks. The largest peak is during the acquisition. So when you buy those materials, when the materials are processed. And then obviously there's a smaller one at the construction, and even at the operation and maintenance, there are some peaks, which are significantly lower peaks than what we have on the acquisition. But still, we want to consider more the operation. And why is that? Is because this one, what you see, okay, so this one, what you see is not to scale, actually. So if you really look at the actual timeline, then we're looking at 50 years. And in a 50-year time frame, these small peaks will actually mean much more than the one-time peak during the acquisition. There is a term here, primary energy. I'm not sure if you're familiar with the term or not, but this one is a very important metric. I'll show you what this actually means. All in all, I think what our main mission should be with any kind of solution is to make sure that we can support the design decisions from the early phases. Why is that? Because in the early phases, we have more effect. So we can affect the design more, and we can affect the operation more because we make the initial decisions. And also when we do these changes, in the early design phase, they cost less, right? If you already have a completed project and then you realize that the operation is not sustainable and you have to do changes once the building is built, then you don't have that many options, and all of them will have a small effect mostly, and they will cost a lot of money. So what our goal is to make sure that in the early phases, starting from the early phases, we can have a control on the energy efficiency as well. So let's see. When we look at the building sector, okay, according to the International Energy Agency, then we can see two things. So a bad thing is that the building sector is one of the largest end user sectors in the energy consumption. You could see this in the donut chart in the very beginning. So actually, we kind of already knew that. Good thing, however, is that if we want to make a change here, then with relatively small efforts, we can achieve quite a lot, because this is one of the most effective sectors when it comes to reducing the energy consumption. So that's at least a good sign. Just a few words about the International Energy Agency. Why should we listen to them? This is basically an intergovernmental organization. It's based in Paris, and basically they provide authoritative analysis. They make policy recommendations to these real world energy related matters. So all in all, it's an international organization, and we definitely should listen to them. And also they came up with different methods. So how, or suggestions, recommendations, how can we reduce the energy consumption? So we already identified that it makes sense to deal with this topic, but how should we do it? And actually there are three ways how we can achieve that. The first is that we implement regulations and codes. So local authorities, governments, countries, they can request certification, right? To make sure that your building is fulfilling certain demands. And this can be mandatory, all right? So basically this is something that the state, the government, or an authority demands from us. Besides this, we can implement green building standards. So basically guidelines how our building can perform better. And this is absolutely voluntary. So it's up to us if we follow these trends, guidelines, methods, but definitely it will help to reduce the energy consumption. And the third one is that if we are already following these green building standards and guidelines, then actually we can also do a performance rating and apply or just basically have our building rated. And this is also voluntary, a voluntary action. So we have these three main means in our hands as a society, as a community, as humanity, basically to reduce the energy consumption. So how does this translate into Archicad or BIM language? What can we do in Archicad? Basically, the first thing is that we should estimate the primary energy demand of the building. So this is going to tell us how much our building, how big is the footprint of our building on the environment. How can we do this in Archicad? We can issue energy performance reports. Okay, so we will see exactly how much is the energy consumption and the performance of our building. The second thing is that if we see this report, then we can see a breakdown of the different energy consumptions, and we can identify what is going to contribute to the energy consumption, right? So we can look at the results and we can evaluate the results and decide which one has the biggest impact, for example. And once we have this, once we define what has the biggest impact or smaller impacts, we can come up with different options, different design decisions, and optimize our solution, optimize our design, right? So based on the report that we evaluated, we can make decisions. So this is what we should follow in a BIM tool. Now, in this case, I'm going to show you how we do this with Archicad. Just a few things to explain a little bit more about the primary energy. So it's one of the best operational energy consumption metrics So what does this mean? So basically, if something has a high primary energy demand, it means that is affecting the environment more than it has a lower energy demand, a lower primary energy demand. So the primary energy is not considering only the building performance, but it's also considering like how the energy is processed. So it means that there are energy industry losses. Basically, that's how the energy is produced. So for example, coal mining, the mining process itself. Or when you transport this energy, if you think of district heating, district cooling, basically the way how the energy is transferred during the way or on the way, there's a transportation loss, right? So basically what we get in the end is much less than what we had in the beginning. And then also when it goes to, when the energy arrives to our building, then even our systems have losses. So for example, you have a hot water heating pipe. If it's not insulated, then there is a heat loss through the pipes. Just a small example. Or when you do the air exchange, there is heat loss or unwanted heat gain in warmer countries, for example. So basically, the energy demand of the building itself is a small piece of this, just a fraction of the primary energy. But overall, if we want to know the impact on the environment, then we should be looking for the primary energy demand. So if you look at the different phases and the different stages of the project, then there are basically, in each and every phase, there is a need for sustainable solutions. So I mentioned in the beginning that we would like to make sure that we have supported decisions from the early phases. But let's see what we're actually doing there. In the schematic phase, in the conceptual phase, what are we doing as architects? We do the massing, we position the building, we set the orientation, we do the zoning, we set up the spaces, and we define some of the building materials. So what are going to be the structures that we're using in this building? And then at the design development, we are going to focus more on the efficiency, right? So usually this is where we fine tune our design as a whole. And create this low energy building design, the improved one. And you may think, okay, now our job is done. But actually, once we move on to the construction phase, construction documentation phase, even there are two occasions when we definitely need to make sure that we have a sustainable solution. One is that if we would like to use the help of an engineer, and we would like to have a third party who will do the energy performance calculation. So usually those people use a different software. So we should be able to export this information to them so that they can reuse it and do their calculations. And then at the very end, a little bit later, we should be able to produce some documentation, standard documentation that fulfills the requirements for the energy performance rating. Right. So basically, this means that the sustainable solution is really needed to be there throughout the whole life cycle as well. Okay, so let's just take a look at the actual workflow. So what is it that we do within the software, or what do we do within the design workflow? So obviously, the very first thing would be the model preparation. This is what the architect does. Right, this happens naturally. Basically, what do we have here? We have the spaces. In Archicad, we call these zones, and basically the spaces will make sure the spaces are already there, because this is how we can check that they are fulfilling the architectural program as well. Right, and once we have the spaces, so the building envelope, the structures. Then we need to make sure that this model, which could be anywhere in the world, is somehow related to the environment and the location that we're working with. And we need to put in some energy related data. So what do we want to achieve inside the building, and what are the outside requirements, for example? And then once we have these things, so once we have the BIM model, we have the energy related information, then we should generate a building energy model. So we had the building information model, and then we need to generate a building energy model for the energy analysis. And once this building energy model is ready, then we can evaluate the performance. And what do we want to achieve with this? So how do we set our model? How do we set up the structures first? What do we define here with the energy related inputs? It's always because we want to fulfill some requirements, right? So even if there is no requirement for ratings, there's always like a building code that is requiring that this building should perform this way. So usually at the first evaluation, we are fulfilling the requirements of what we call the baseline design. Basically, this is the bare minimum that is required usually. And if we fulfill that with certain design decisions, we can improve that and make our building better. So what can we do? We see the baseline design performance, and based on that, we can come up with an improved design. This can mean architectural improvements, changing the shape of the building. I will show you some of the options later on. Or I can change the building energy model as well directly. Or anyways, once I created my improved architectural design, I just regenerate the improved building energy model. And once I have a new building energy model, then I can run again an energy evaluation. And now we have two energy evaluations. Once we had the baseline, that was the bare minimum. And then there is a design option, which is an improved version. So this gives us the opportunity to compare them and see how much better the design option is. All right, and then we can choose whether we are going to improve it further or if this one is okay. If this is okay, then we can move forward towards the certification. So our goal is that the BIM, the building energy model, can be exported for certification and can be given to an actual engineer who is entitled to do a certification. Okay, so let's go through these steps. So what can we do in case of, for example, the model preparation? You can see there, this is a small building, but it's a very nice example, and I will be able to show all kinds of aspects of our energy analysis workflow. This one is a relatively detailed model, but we don't have to go into every single detail when it comes to energy evaluation. We can do it gradually. So we can do energy evaluation in the early phases. And as the building gets more refined, we can get more detailed on energy analysis as well. So you can see here the building itself. Basically, our first goal is to filter that this building, actually not everything is important when you look at it from energy evaluation aspect. So what is important? The envelope, because that is connecting the internal space and the internal requirements with the climate outside, right? So we need to make sure that the external envelope is given. But for example, furniture is not going to affect the energy performance. So in a BIM software, it's very easy to create different views of the same model. If you're using 2D CAD, you cannot really do this, because in 2D CAD, basically for different representations of the same content, you have to recreate the content. In a BIM model, this is good because we have one source and we can look at it from different perspectives and different points of views. So one point of view could be the architectural model and the architectural documentation, the one that you can see on the left side. And then there can be a view, which we're going to be using for energy analysis. So basically, this is just one setting which can be predefined, and we can very easily switch to this. So this will only include the energy related geometries. Even the surroundings are good to have them involved because they can provide shading and they can provide wind protection, for example, which can also affect our energy performance. But this is what the architect can do. And besides that, they can also use this palette in Archicad, where we can put in the energy related information. Okay, so first energy related information could be thermal blocks. So what is a thermal block? Basically, the spaces that the architect has already defined have to be organized into thermal blocks, which is going to be the logical connection. So we need to connect the internal requirements that, let's say, this is a meeting room with this and that temperature requirement. And we need to link it with the structure and the environment outside. So a thermal block is good to collect those spaces which have the same functionality, and therefore they have the same internal requirements. They have the same orientation, and they have the same building systems. Okay, so we can create these thermal blocks. Again, the architect can do this for the energy evaluation. Okay, moving on, we can have the environmental inputs, right? So what is the climate at the location? What is the climate like at the location? Archicad will automatically download climate data from the internet based on the location settings of your project. But if you don't find that good enough, or if you have your own preference, you can get this climate data files from the internet. There are local sources, there are international sources. Basically, you can also import that, and then it is going to define how the environment is like. So if it's how is the moisture, how moist the climate is, what is the temperature distribution, precipitation, how windy it is. And besides that, you can also set up the immediate environment of your building. So in this first dialog, for example, you can set what is the wind protection, or if you have horizontal shading, what type of soil you have, what is the reflectance on the soil. Just think about this: if you have a brighter soil type, then that is going to reflect the heat, and that is going to be a hotter environment around your building. So you can set up these values as well. You can use the overall values for the climate itself, and you can set up these the wind protection itself, because what you see here is that there is the wind direction that is coming from the climate. But you can analyze the environment, and you can say that even though that the southwest wind is the strongest, we don't have wind protection there. So you can see that basically the wind protection southeast, southwest is unprotected. So basically this can be an area where we should probably do something to eliminate the effects of the wind. All right, so this is just a small analysis, and also this data will be used later on for the energy evaluation. Okay, so as I mentioned before, we have the spaces, and we can create these thermal blocks. Okay, so here's where you can see the actual thing for the thermal blocks. You can have as many thermal blocks as you want. You can have as many zones and spaces in the thermal blocks as you want. Again, the good thing is that these spaces will already be there because of the architectural design. Because you have a program, you have to fulfill a certain GFA floor area, and you have certain amounts for the different functions that you need to provide in the program. So these different types of spaces will already be there. And for example, if you have two of the same kind of zones here, then you can put these into the same thermal block because they are located in the same position and they should work and behave the same way. So we put together the thermal blocks, but then we need to define like what is the function of the thermal block. So we know that a meeting room, that these spaces are going to be meeting rooms, for example, but what does that mean that we have a meeting room? So we can set up these operation profiles, which is going to set the internal requirements. And you can see that even in case of a meeting room, these spaces work differently depending on which day of the week we are. So for example, on work days, we need the meeting rooms to be having a different climate than during non-work days, during the weekends. So here you can see that we can go into the details and we can say that this is what is the work day from Monday to Friday all year. That's the work day. And what does it mean that we have a work day? In a work day from 7 a.m. to 6 p.m., we should be having a minimum of 20 degrees and a maximum of 26 degrees. So this is what we should fulfill. And obviously, besides this, we have internal heat gain. There are people inside the space who are breathing, sweating, basically producing the heat. And there is also equipment, building services, office equipment, or there's also lighting and electric equipment, which all generate a type of heat. Right? So we need to basically later on see if this is good for us, this extra heat, or if it's bad for us. Let's see. So when it comes to this BIM model, the building energy model generation, basically there are two things. So one thing what Archicad can do. So Archicad will take the geometry that you built, will consider the building materials and the windows, doors, the openings that you defined. And based on this is going to generate the building energy model, considering these space boundaries as well. So this is what Archicad can do. The architect, what is the architect's responsibility is to make sure that the structures and the openings are correctly set and improve them. And regarding the openings, we can also run solar analysis. And based on the result of those solar analysis, we can decide whether we should improve further our model or is it okay as it is. So let's take a look at the structures and the materials. What can we see? Further down on this energy model review palette, this is the next page. You can see we saw the thermal blocks before, but the next page would be the structures. So you can see that in this small building, these are the different structures that you have in the model, and they all have certain values. For example, the U value, which is representing the thermal transmittance or infiltration value. Basically, this is telling you how solid the structure is. Lightweight structures have more infiltration because they have gaps. A concrete structure has less infiltration because it's basically one solid thing that you cannot penetrate. There is solar absorbance, how much energy it is absorbing from the outside, for example. So these are values that can be very detailed. And obviously you can say, how would I know all these things in the early design phase? Well, the good thing is that you don't need to know these. I mentioned in the beginning when I showed you the building that this is already a detailed model, but in the early design phase, you can just override these values. So you can say that you're not having an exact structure. You just say that I'm going to have a slab, I'm going to have a wall here. And you can say that I'm going to manually override the U value. So I want to ignore the actual performance and I want to use something that is required. So let's say if locally this is a required value, I can just put it in and say that no matter what, this structure should fulfill this value. Okay, so when we do this, it is going to be good for us to do the design demand calculation. Okay, you will see exactly what that means. And then later on, when we refine our actual structures, then we can make sure that the actual structures fulfill the values below this. And later on, we can also calculate with those to have the actual performance. Okay, but what matters is that in the beginning, we just say that I don't know how it performs, but it should fulfill this requirement. So we just put in the requirement. We can do the same thing with the openings. So you can see we are now at the next page, the openings. All the windows, doors, which are facing the external, facing the exterior, can be defined. So you can set the materials for the frames, you can set the materials for the glazing itself, and then they are going to have a certain combined value. Obviously, whichever values you choose, that's how it is going to affect the performance. Okay, so these were the structures. But let's move on to the building systems. Obviously, what are the building systems? It's really affecting the performance. But then again, we are in the early phase and we are architects. So how should I know what is going to be the building system? Well, the good thing is that you don't have to know it again. So probably what you can also decide as an architect is that what are the actual types of systems, right? So are you going to have heating? Are you going to have cooling? Are you going to have ventilation? At least this you can still decide. The details, those should be coming from an expert. So how do we tackle this? In the design phase, you can say not yet specified. So not yet specified means that it is just going to fulfill the requirements. So let's say previously in the operation profiles, we said that we need our meeting rooms to be within the 20 to 26 degrees range. And if you set up a cooling or a heating system, if you set it to not yet specified, it means that it is just going to keep between 20 and 26 no matter what. Okay, so this is going to be good because all those results that we get in the energy evaluation will be used for the demand calculation, right? So we know that this is the amount of energy that is needed to fulfill the requirements. How are we going to fulfill? We're going to do that later. Okay, but just by setting not yet specified, we can do a demand calculation. Okay, moving on, we can run the energy report, energy evaluation, and create an energy report. Here, this is an example. On the left side, you have different chapters of the report, and you can choose whether you want to include those chapters or not. So this makes it a configurable report. And it's very interesting, actually, what you can see, for example, in case of the project energy balance. So you can see that the solar gain is quite high. So just remember that this is a European project. So in this case, what it means is that during the summer, there is a rather large solar gain. So based on this, we can consider that we should apply some shading, right? Because this is the bigger portion. So somehow we could work on the solar gain. That would be good. Okay, heating. Again, Europe in November, December, January, February, March, we are using heating because it's winter time. That's no surprise. But even during that time, we have a little bit of solar gain, right? So actually that's pretty good because this solar gain helps us to reduce the actual heating. So in the Southeast Asian context, obviously this would be the opposite way around. But you can see the ideas, what you can read from these, right? Also what we can see, human heat gain, that's basically all the same throughout the year. And also lighting and equipment, that's also the same throughout the year, which means that during the whole year, this building is used pretty much the same way. What do we see? So this was the supplied energy, but what is the emitted energy? Okay, we lose a lot of energy through transmission. So, well, you know, one thing is that we have a lot of heat gain, and then we also lose some of the energy. The problem is that if we have heat gain, heat coming in and then cooling going out, then you know it doesn't really work. So we should see also how we can improve the structures to reduce the transmission. Infiltration is relatively low, so it means that our building is airtight, and you can see that again, since we have the heat gain, there is a counterpart. We need to do cooling during the summer. Okay, so these are results that you can evaluate. You can have a breakdown to the different thermal blocks as well, so not just an overall energy balance. And based on that, you can see that, okay, we need to improve mostly the meeting rooms, or maybe we need to improve, you know, the circulation areas, just an example. Okay, so here is the final report. So as when it is published as a PDF, here is another breakdown. For example, this is showing you the actual performance and the climate requirements. So this is what we call a daily temperature profile. So the red part is what we set up in the operation profiles. The blue part is the external temperature. So we can see that just by using those building systems that are not specified, but we know that they will fulfill the results, this is how they are going to work. So the light blue is going to be the actual internal temperature. So obviously what you want to achieve is that the light blue should be within the red range, even later when you actually define the building systems. Right, so there's an interesting one here. The light blue is a little bit outside of the range. You will see later what this means. Okay, and probably the most important thing is that there is a chapter that we call design data. So this is where you can see those heating and cooling demands of the different thermal blocks. So you can see how much cooling is needed throughout the year, how much heating is needed throughout the year. And this is what we can use now. So basically we have those peak demands. So based on that, I can say that, okay, if the exhibition area needs a heating demand of 2.5 kilowatts, then basically all in all, it's 11 kilowatts of peak demand. I can choose what should be the performance of the actual heating system. All right. So basically we said that whatever we use is going to fulfill the requirements. This is what they need to fulfill. And now later on, we can put this information back into the system. Okay, so let's see the optimization workflow. We run this first version. So we know that this is going to happen if we just fulfill the basic requirements. So we already did this. We created a base building, which was without systems, without specified systems. We ran the energy simulation, and based on that, we could define the demands. So we set the demand calculation as well. So now we're actually going to review the energy performance. That's also what we did when I just explained to you that this is where we have the heat gain, this is where we have the transmission. So we did basically all these three things. At this point, what we need to decide is how we're going to improve this. Okay, so we have to investigate the optimization options. What is feasible, what is doable, what works within this particular environment, what doesn't work can we afford it, how soon it can be implemented, and so on and so forth. And once we identify these different options, then we should also investigate how well they actually work in this situation. So that's when we can do these sensitivity analysis. Okay, so what does this mean? In this investigation, we figured out that we should do shading. Okay, then we apply the shading, we run the energy evaluation again and see how much is the improvement. Okay, so we can see this with the different solutions. It's up to us. It's not a must. Obviously, as you are more experienced with this whole optimization, you have a very good idea which solutions you should use. And basically, you can do this all at once. So if you say that, yes, I will have to use shading, I will have to use better structures, I will have to use renewable energy, okay, that's fine. We can apply that all at once. And basically, this is what we define here, a project-specific low energy solution set. Okay, so these are basically the improvements all in all. And actually, there can be three kinds of improvements. One is what the architect can do very simply, more or less simply, by changing the design, saying that we're going to have, let's say, smaller windows, or we're going to have this shading in front of the building, or we are just going to rotate a little bit, let's say, the building to have a different orientation. Or we can change the building systems and replace them, make them more efficient, or we can apply renewable sources as well. So these are the three ways. And basically, once we decided how we go forward, then we're going to define the building systems with the actual values based on the design data. And basically now our final building is done. So then we can run the energy simulation again. And this is when we have the design version, which we can compare with the baseline building. So we can see that overall, how much is the difference? How good is the improvement? Okay, so to give you some idea, what are the approaches when we want to optimize? So there are two approaches, active and passive approaches when we want to optimize our building. So the active optimization is when we ignore the environment and we just take the building on its own. So architecturally, what we can do, minimize the transmission. This is basically what I roughly explained just now, that we can change the shape, or we can improve the structure, or we can make sure that there are less gaps around the building, so it's more airtight. Solar heat gain is reduced, and we are using different energy resources, basically. And then passive is to cooperate with the environment and make sure that we are using renewable energy sources. Typically, it means solar energy, but you can also think of like heat recovery. Again, it's more of a European use because of the climate. I mean, not European use, but more of a different climate, more related to the different climate. When you have the used air, that's already heated, right? So if you take the fresh air, you can have a heat exchanger and basically use the used air to warm up the incoming air. So that means that you save on the heating itself because you preheat the incoming fresh air, right? So basically, that's also a passive way of optimizing your project. So, but what could be these solutions? Again, there's this IEA research. And there's a statistical data on the efficiency of the different solutions. So you can see here 3 different climates: cooling dominated, heating dominated, and mixed cooling and heating climates. Most of Southeast Asia is cooling dominated, or maybe Northern part of the, Vietnam could be mixed cooling and heating. And you can see that what is most effective here. This is what an architect can do. This is what we can achieve with the building systems, and this is what we can do with using the renewable energy sources. So the architect can change the shape of the building, improve the structures, add the solar shading, and apply natural ventilation, right? So this is what an architect can do, and that has a rather high dominated environment. So what can be an energy efficient solution? If we reduce the energy consumption of the lighting or the equipment itself, right? So if you think about this, we have many these offices in Southeast Asia. They're constantly exposed to the sun. So we're doing a lot of cooling internally. But it's not just the sun that is heating up our offices, but it's also the equipment that we're using inside. So if we have a better office equipment and better lighting solutions, then we will need to have less cooling, right? Then the renewable ones, renewable solutions could be the solar panels for producing electricity, for example. Okay. So these are just a few examples, and based on this, we can choose how are we going to improve our building. Okay, so let's see how we can actually do these improvements within Archicad. If you go to these operation profiles and set up this daily profile, you can see that at the bottom we could define what is going to be the occupancy, but how much is the performance, or how much is the wattage of the lighting and the equipment. So these ones are, you can use the defaults if you're not familiar with these numbers, or you can just do some research on some rules of thumb. But basically what you can decide is to say that, okay, we're not going to use the fluorescent lighting too, but instead of that, we're going to switch to LED lighting. So obviously that is going to have less energy demand. Okay, so this is one. Then going back to the structures and the materials, you remember I mentioned in the beginning that first we just put in some manual values. So we did a manual override and we said that it should be 0.28 because this is the local requirement, let's say. But now actually when we look at our structures and we already have a detailed building model because we need it anyways for the architectural documentation, there we have composite structures with building materials. And these building materials are actually not just 2D representations and not just a hatch that we say that, okay, this is going to represent brick or this is going to represent concrete. But these building materials have actual physical properties. So for example, there is the thermal conductivity and that's what you're actually going to use to calculate the actual U value, the actual heat transmission of the actual structure. So you can see that if you're using this type of structure, then there is an actual calculation. Does that fulfill the 0.28 or not? If not, then we can say that, okay, maybe we should increase the thickness of the insulation. And let's see, real time, you can see what is your actual U value. But there's even more because we can consider even more details when it comes to the energy evaluation. You can see that under the structures, besides the structures, we can see what is called a thermal bridge. So what is that? Basically, when you have your building, you have typically the openings. As the openings are installed, there there are usually small gaps, and these are critical parts because you have to make sure that the heat insulation is continuous. So there are no gaps where there could be heat transmission. In Europe, it's very important because that's where if you have a gap, then the cold or actually the heat from the inside will just go out through those gaps. And then obviously that's a heat loss. But the reverse of that is also true here in Southeast Asia. That's where you can get unwanted heat gain, because if you have gaps here, then the heat is just going to come in here. It is going to be warmer inside, and then you need to have more cooling, right? So basically the heat is not just coming through the surface, but at the gaps as well. And if you have a huge building, you have the curtain wall all around the building, that's a huge perimeter where you can have potential gaps and potential heat transfer. So if you create details to the details of this particular location in your building, then you can use that detail to generate this heat transfer analysis, okay? And you can visualize it by showing the different temperatures or showing the energy flow itself. So basically this is the result, which is very easy for even for the client to understand, right? That okay, again, this is European, so it's winter outside and it should be a normal temperature inside, 26 degrees. So you can see that this is the warm part, but because of the heat insulation, it doesn't go out. I mean, obviously there is a little bit here because this is a metal frame, but basically it kind of stops there. So this is a kind of okay solution. But if you see that this solution is not good because the heat is traveling through, then you can improve the detail, you can run the visualization again, and you can have the second option, and you can convince easily the client, this is why you chose what you chose. Okay, so you can visualize it as well. But what is more important is that the effect of this heat transfer can be considered in the energy evaluation. Okay, so if you have different details in your project, then you can do a linear heat transmission calculation, which can be added to the overall calculation and make it even more detailed. Okay. If you look at the openings, then it's possible to run this solar analysis. And then again, you can see that there are two options. Basically, the percentage of glazed area exposed to direct sunlight. So basically, this means that this particular window or door that we see here in the list in June, or basically throughout the whole year, is not exposed to the sun in the afternoon. During the day, it is exposed. So based on this, we can consider that we should put up some shading, because in June, July, this is going to add to the internal heat gain. I mean, it will add to the solar heat gain. Okay. So these were the structures and the openings. And what can we do in case of the cooling systems? If we want to now really specify what is going to be the actual cooling system. Well, the good thing is that, again, we're looking at ourselves as architects and not as experts. So in this case, we can choose whether we're going to use the basic or the expert options. In Archicad, you can use teamwork very easily. You can connect MEP engineers to your project. So actually, they can also set it up for you. Okay, so they can change the expert settings. And this is just an example. They can go into all kinds of details. They know, based on the demand calculation, what kind of equipment should be used. So they will just put in the equipment characteristics into the system settings. Okay, but if you don't have that, you still can go with the basics, and you can have an estimate for these inputs. Here's another example. So the previous one was for the cooling. This one is for the heat recovery. Basically, they can set up exactly what kind of components these air handling units will have. And also they can set up the operation schedule. So the operation schedule should be synchronized with the operation profile. Because in the operation profile, we said that from 7 a.m. to 6 p.m. we should have this temperature. So that also means that, okay, our air handling should also work in the same time frame from the morning till early evenings. And then also there are the renewable sources. For example, the photovoltaic panels, you can set up the type, where they are placed, how much is the area of those, and so on and so forth. Okay, there are two very interesting settings as well. This is mostly needed in the end of the process. You can ignore them as well, but if you incorporate them, then you can also have you can measure the savings as well. So the first one is the energy source factors, which is basically defining. Okay, so here you can define the distribution, the proportion of the different energy types or the different resource types that you're using for electricity production, for example, right? Or for example, here you can see that it's like a multiplier for the actual demand, actual building demand, and the relation between that and the primary energy. So basically, you can see that those natural resources, basically there is no loss here. If you're using oil, then basically the primary energy is going to be more than the actual building energy demand. So you can use the standard values, and basically this is what you should be using based on the local conditions, right? So if you don't have coal power plants, but you have nuclear power plants, then obviously you would go for more nuclear energy and less coal. This will affect the primary energy demand because this also defines the efficiency of the local systems. And it's also affecting the cost because the different sources have different costs. And this is what you can actually set up here, the actual energy costs. How much does this energy cost in your country? And finally, we're running again this energy evaluation report. So here, this is just a snippet of the comparison with the baseline building. So it's very interesting. You can see that the new design, the heating and the cooling, they cost £57 a year. So this is a very low, these are very low amounts. I haven't mentioned, but the building is a so-called passive house. So it was a very special construction because it has like 50 centimeters of insulation around and very efficient shading and building systems. And that is basically, that means it has heat recovery as well. So basically this all in all allows us to have a very low amount of yearly maintenance costs. Okay, this is what you can see from the report. And then you can also have the cost of the renewable energy, and also here the primary energy and the carbon dioxide emission as well. There are some advisory messages. So for example, unmet load hours means that there are those heating hours when the internal requirements are not fulfilled. And you remember when I showed the previous report, the blue line was a little bit out of the red part. So basically that meant that when we have the requirement, we turn on the equipment, but the equipment needs some time to provide the requirement, right? So the requirements are not fulfilled right away. So that's why we have these very minimal amount of 57 heating unmet load hours. We can improve that if we want, and we can say that actually the equipment should turn on earlier than the actual requirements, and then we can probably get rid of these, or we can just leave it because it's fine. Anyways, this is automatically coming out, and then we can use this for evaluation. Here is a comparison of the costs. So you can see this is the baseline building. The baseline building was using almost £3,000 a year for the overall electricity costs. But now this new proposed design is only £500. So basically we can compare. So we save 82% of the costs if we use these new solutions. Okay, so actually this is the important part. We can use all kinds of solutions, but can we compare them with this solution? Obviously, yes, we can. Okay, so here I think this is very, very important that you can see how much your actual savings are if you follow the new design. Okay, and then there is this one when we define the baseline performance, you can see that actually there are 4 evaluations. This is because of the Ashrae standard. The Ashrae standard requires that you take a look at your building from 4 different directions, and then it creates an average. And that's also how the baseline energy costs will be generated. So that's basically part of the standard evaluation, that we look at it from different orientations. Okay, and this is also very interesting, the performance rating table. So here you can see that this was the original, and this is the proposed design. And you can see that in case of cooling, we saved almost 90%. So which is a huge saving, and that's the key thing, that we are aware of this. And if we do this, okay, you can see that in case of lighting, when we applied the LED lighting, that meant 95% saving. So on the contrary, heating has actual loss, which is 12% of loss. But because it's a passive house, the heating in general was very low demand. And anyways, we can say that the 20% loss is far outweighed by the 90% saving, right? So even though here we have a little loss, there's much more that we gain here with these savings. So without a BIM model, without the energy evaluation, you cannot evaluate this. Okay, and how can we get this to the professionals if we want to do certification? GBXML is one of those open formats that is commonly translated and understandable by the energy evaluation tools. So here on the right side, you can see what is in Archicad, and this is a GBXML viewer. So this is what we export to the energy experts. Okay, and then they can do their actual calculations and do the certification based on that. You can consider the GBXML as a universal format. So in case of model exchange, IFC is similar to that among BIM applications, or a more common example, PDF is something that is known for everyone, and it's generic file format. So GBXML is the same in terms of the energy analysis. There's this PHPP, Passive House Planning Package, which is a German solution and a German standard. Basically, this is an Excel sheet, and we can provide the input for this Excel sheet. It has less relevance here, but it is also one of the standards. So definitely I wanted to mention this here as well. Okay, so we have all kinds of results. They look very promising. They are really good, but can we trust these results? I mentioned before that we are using the Ashrae standard for the simulation. So basically the simulation itself is certified by Ashrae. So what is Ashrae? It's American Society of Heating, Refrigerating and Air Conditioning Engineers. So it's basically a technical society, but what is important is that they are developing and publishing technical standards and recommendations. And basically all this is to advocate the sustainable development, right? So they describe the technical aspects for a reliable simulation, basically. And this Ashrae standard means that there is a standard method how the energy evaluation tools are tested. And here are the results of different tools. So basically, if the tool conducts the evaluation and the result is within a certain range, then that solution is certified. Okay, so in this case, EcoDesigner and Archicad, they are the red line, and also here EcoDesigner is the red result. So it's pretty much within the range, and hence it is an Ashrae standard compliant simulation. So where else Ashrae is used? It's basically a testing method that is referenced by most of these major sustainable design regulations. So all around the world, you have these organizations and rating systems, and they support and refer to the Ashrae standard. So just to give you a few examples, DGNB and Passive House from Germany, Green Star and Nationwide House Energy Rating Scheme from Australia, LEED from the US, CASB in Japan, BREEAM in UK. They all refer back to the Ashrae standard with their own certifications. So I think we can say that we can rely on the results, right? So all in all, if we go back to the original mission, I think you can clearly see that we support the early design phases, and by this we can definitely make the best design decisions. We can compare them, we can evaluate them, and eventually this will have effect through the whole life cycle of the building, especially the operation and the maintenance. So this brings me to the end of it. Thank you for your attention. I hand it back to Min. If you have any questions in the chat, or just you want to reach out to me, feel free. Here's my email. Thank you for your attention.
Thank you, Sandor. That is very detailed presentations on the tool. I hope you are not too tired with your speaking.
Yeah.
Vâng, xin cảm ơn tất cả mọi người đã chú ý lắng nghe anh Sandor vừa chia sẻ về các cái yếu tố liên quan đến việc sử dụng cái công cụ có sẵn ở trong phần mềm Archicad cho việc tính toán cái hiệu năng sử dụng năng lượng của các công trình. Thì như các bạn cũng anh các chị cũng đã vừa được nghe thì cái công cụ này thứ nhất là nó đi kèm với cả phần mềm Archicad, nên là nếu mà các anh chị có phần mềm Archicad và cần phải tính toán hiệu năng cho sử dụng năng lượng trong công trình thì các anh chị có thể sử dụng luôn cái công cụ này mà không cần phải mua thêm một cái công cụ nữa. Bởi vì như ở đoạn cuối của cái bài trình bày của mình thì anh Sandor cũng có nhấn mạnh là công cụ này đã tuân thủ đầy đủ các cái tiêu chuẩn của Ashrae, tương đối có thể thấy được là cũng cái kết quả thu được trong cái quá trình cũng có thể thấy được là khá là phù hợp với việc tính toán. Tiếp theo là phần câu hỏi. Sandor, there will be a couple of questions as you can see on the screen.
Okay.
There are some questions at the bottom. It's in English already. Nhờ bạn Đạt có thể kéo xuống luôn mấy câu hỏi bằng tiếng Anh để cho anh ý trả lời trước được không ạ? Yeah, those are the questions in English. I hope you can see
Yes.
it clearly.
Yes. Okay. So which one should we start with?
Well, just from the top first.
Okay, so yeah, does Graphisoft has guidelines to use the Eco Designer Star tool? Well, we have these workflow videos where you can request trainings from our partners. We also have a Learn portal, and sooner or later we are going to have some materials related to Eco Designer Star as well, for sure. But until then, you can find there are 6 videos which are going through the different workflow stages. So basically, those things that I showed you today, there is an example project, and it goes through the process.
Okay.
Okay, the next one.
Yeah.
Describe the inputs for energy simulation in the specification and property in Archicad for later use. So I'm not exactly sure with this one, but I mean, I don't really understand the question, but basically whatever you put there as an input will be there in the exported GBXML file if you export it, or in case of Archicad, then you just carry it on with the model. So yeah, I'm not sure if this was about it, but that's how I understood this. What calculation engine is used for the simulation? So the engine is the VIP energy. So that's developed by Strusoft. It's a Scandinavian firm that has its own energy evaluation tool, but the engine is also what we use within Archicad. Okay, maybe the third one, if you can help with the translation since it's here.
There will be more English question for you first.
Okay.
Yeah.
Okay. So yeah, the BIM the model BIM output the required information calculations according to the edge lead green building only signal. Okay, I'm not sure if this was exactly the way it was asked, but for the lead again, you can either use the GBXML export for those applications that will do the lead certification. You can use the results as well for input there. Okay, basically what we say is that the calculation method, the results are reliable because it's using the same standard that is referenced by lead as well.
I think the next question is very favorable. It's directly related to Vietnam for actual calculations. Yeah.
Yes. So basically, you don't need to adjust the calculation itself, but it's the climate file, the weather data that you're using for and those websites where you can get the climate data, they basically provide that for the whole world. So as I mentioned, if you set up the project location coordinates, then Eco Designer will automatically download the weather file from Strusoft because Strusoft has their own weather files, and that will automatically be linked up with it. So right away you will have the Vietnamese climate conditions, and you know what you need to do as a manual input is the energy source factors, right? The proportions of how the electricity is produced and the energy costs. So that is your manual input. And also when you have the requirements, heat transmissions factors, then you can use your own requirements. So basically that's it. You customize the whole thing to the local conditions. if you're not happy with the climate file that we automatically get from the Strusoft server, then you can also download your own climate file, because honestly, I haven't checked it for Vietnam, but obviously there can be quite the difference between Ho Chi Minh City and Hanoi. So maybe Strusoft is only providing weather data or climate data for one of them. But then you can go to the internet, look for these IWEC files, and I'm pretty sure that there you will find whatever you need there. It's happening in the bigger countries that there are more cities available, but if not, then you can just find those weather files online.
Okay, thank you, Sandor. I have a few other questions in Vietnamese. I probably translate it to you. The latest one was, when you buy a full license Archicad software, can you use this Eco Designer Star tool?
Okay, so not the full capabilities. So in the basic energy evaluation, which comes with Archicad, you can still run the energy evaluation. You don't have the comparison, and you don't have the expert options for the building systems. You cannot compare the cost differences. You cannot compare with the baseline. I mean, you can do it manually, but you cannot have it in a report. And you cannot have that detailed report breakdowns in the basic version. So the basic version is still good to evaluate design options, but you cannot have a full documentation out of that. So it's just basically you can use it only inside Archicad for your own evaluation.
Okay. Hôm nay thì anh Sandor có trả lời cho câu hỏi vừa rồi về cái phần nếu mà mua bản quyền Archicad thì có sử dụng tính năng này được không? Thì trong phiên bản này thì nó sẽ có hai phần, phiên bản cơ bản đi kèm và một phiên bản nâng cao với đầy đủ các tính năng hơn. Thì khi mà mua cái phần mềm Archicad có bản quyền thì cái phần tính năng cơ bản sẽ được có đi kèm luôn, miễn phí, và nó cũng tính toán được khá là đầy đủ. Tuy nhiên nếu mà để có được tất cả các tính năng thì có thể là sẽ phải mua thêm một số cái phần khác. Another question is, can Archicad do all the functionality of BIM? Like can it basically can Archicad replace the use of a BIM software?
Probably not, because you need to have an expert for those final certifications. But basically where it helps is that you don't have to. So what we see in the industry is that converting a BIM model to a BIM model, that is the missing link, right? So how can you transfer your model to a third-party engineer? So one thing, what is the goal with the Eco Designer Star is that you can have a valid standard compliant result, and then that's good for you to improve the project, make informed decisions. You can tell that to the client and convince them about those solutions. This is one thing. And then if you want to have a full certification, that's probably a separate qualification of someone else, right? So you probably cannot do the certification yourself because you're not entitled to. But then you can just transfer the model, or actually the model data, the BIM model, to the engineer as is, and they can right away use it.
Okay, Thank you, Sando. Can Archicad export the model to Tekla and vice versa?
Yes, through, I mean, this might not be related to Eco Designer Star, I think, but that's when we use the IFC, which I actually mentioned when I mentioned GBXML. So IFC file format is supposed to be the universal open standard between the BIM applications. So if you want to transfer the model and the non-graphical information, then you use IFC format. And that's actually not just for Tekla, but basically between all the BIM applications. IFC is the only open standard. All the other formats are proprietary formats, and therefore they have limitations because they are always the native format of a vendor and not a commonly understandable language.
Okay. Để trả lời cái câu hỏi này, thực ra nó cũng không trực tiếp liên quan đến nội dung của cái buổi webinar ngày hôm nay của chúng ta. Tuy nhiên là anh ấy cũng cố gắng trả lời. Thì Archicad hoàn toàn có thể xuất được mô hình sang Tekla và ngược lại thông qua cái việc sử dụng cái chuẩn IFC hay là một cái chuẩn mở mà có thể tương thích được với có thể tạo ra cái file tương thích giữa file và mô hình tương thích giữa các phần mềm BIM khác nhau. Có các cái chuẩn khác, tuy nhiên các cái chuẩn đấy thì đều là những cái chuẩn mà của các cái hãng đưa ra, và nó thường là sẽ có những cái yếu tố liên quan trực tiếp đến một cái phần mềm hay một cái hãng nào đấy, thì nó cũng tương đối khó cho việc tương thích với các phần mềm khác nhau trên thế giới. Thì tuy nhiên Archicad để tuân thủ theo tiêu chuẩn Open BIM và sử dụng cái mô hình IFC để mà có thể xuất file ra, và khi mà các phần mềm khác nhận được cái file IFC đấy thì hoàn toàn có thể tích hợp vào trong phần mềm để thực hiện các phép tính toán hay là thiết kế hay là thay đổi gì đấy. There is a question from a participant follow us on Facebook for today webinar. Is the question is during the energy evaluations, how do you where do you get the input for the energy uses? Where did you get that for the constructions and buildings in Vietnam? It means like in case that there is no input data for existing constructions or existing building or during construction building in Vietnam, they don't have that kind of input. In that case, can you still use Eco Designer Star to calculate the energy uses?
Okay, I don't really get which input we're looking for now.
The question is it's a input related to the energy uses.
Okay, so I would say, okay, so energy use, that could be the operation profile.
The input is for the setting the model. For the model preparation, then you need to have input for the model.
Okay. Okay. So so in the model preparation, obviously, as an architect, you don't have these inputs. Only when you start working on a BIM energy model, and that's when we put the spaces into thermal blocks. That's when we define what is going to be the function, and that's basically defining what is going to be the energy use. And then also when we provide the building systems, that is also putting in the energy use, right? Because then we define that, okay, we're going to use renewable energy, or if we're going to use this type of cooling or that type of cooling. So that is also kind of defining what is going to be the energy use. Operation profiles are okay to set up for the architects, but you can even use the defaults. But that's very easy to set up because it's plain language. So architects has no issue with that. It's not a technical part. The building systems is a technical part, but even there, you can use the basic setup or just say not yet specified. So if you use the not yet specified, then basically it is going to give you the demand calculation, and you can still get the overall energy performance of the building. There is also input which is coming from the environment, because if you have surrounding buildings, that will affect the shading. So if you can have those modeled, even just as blocks, that would also affect the accuracy of the final result. But so you also ask, if you don't have that information, can you still run the evaluation? Definitely you can. It may not be fully precise regarding the end result because you don't have all the inputs, but you can still compare your own design. So what you can affect, right? Because based on the two reports, the baseline and the improved design, you can still compare if your choices, your decisions, your design decisions have a good effect or a bad effect, right? So definitely, even if you cannot complete everything, you can make use of this.
Okay, thanks, Sandor. So a few next question I will directly to Mr. Kiên, Director of VN Co, so you can take a break. Thưa anh Kiên, là có một số bạn có một số câu hỏi liên quan đến nó khá là liên quan đến phần công trình xanh, chứ không trực tiếp liên quan đến phần mềm, thì em xin phép nhờ anh Kiên, giám đốc của VN Co sẽ hỗ trợ giải đáp cho các cái câu hỏi này. Một số câu hỏi các bạn có hỏi ở trên đây thì sau khi anh Kiên có một số câu trả lời thì mình cũng sẽ nhờ anh Sandor trả lời tiếp. Câu hỏi của một số bạn ở đây sẽ là như thế này ạ. Ở Việt Nam có văn bản hướng dẫn tính phí tư vấn thiết kế công trình xanh hay không?
Cái này thì chắc là mình sẽ nhờ anh Bình là bên Viện Kinh tế trả lời, bởi vì theo mình biết thì là trước đây thì cũng đã có một số cái nghiên cứu về vấn đề là các cái chi phí liên quan đến công trình xanh, đặc biệt là cho các cái dự án sử dụng vốn ngân sách. Thì cái này Bình ấy, có thể nhờ Bình trả lời giúp cái câu hỏi này được không?
Anh Bình không biết là có quên bật mic lên không?
Dạ, có. Không biết là em muốn hỏi xem là người muốn hỏi là xem cái phí để chứng nhận hay là cái phí của công trình ạ?
Câu hỏi đây thì cái người hỏi thì không viết tên nên là câu hỏi nó cũng khá là chung chung. Thì câu hỏi chính xác là ở Việt Nam thì có văn bản hướng dẫn cho việc tính phí tư vấn thiết kế công trình xanh hay không?
Rồi có tính phí thiết kế công trình xanh hay không thì về cái nội dung này thì chắc là có thể anh Kiên thì sẽ rõ hơn, do là cái thời gian này thì bên em là đang chủ yếu nghiên cứu về cái mảng gọi là chi phí cho công trình, chứ cũng chưa ấy, thì xin phép là anh Kiên trả lời công trình cái câu hỏi này.
Ok, thế để mình cũng xin phép là được trả lời câu này, tại vì thực ra là cái chi phí hiện nay cho công trình xanh ấy thì thứ nhất là nó sẽ bao gồm là chi phí đăng ký và đánh giá, thì cái này thì được public công khai bởi các cái hội đồng công trình xanh, ví dụ như là của Hội đồng Công trình xanh Việt Nam thì sẽ có cái chi phí riêng của họ, và Hội đồng Công trình xanh Mỹ hay là bên IFC chẳng hạn đấy, thì đều có cái công khai cái chi phí này rồi. Mọi người có thể lên cái trang web của các cái hội đồng đó để chúng ta xem cụ thể các cái chi phí, bởi vì thường nó sẽ căn cứ vào quy mô của dự án, ví dụ là tổng diện tích sàn chẳng hạn đấy. Thứ hai nữa là cái chi phí liên quan đến cái việc là thực hiện các cái giải pháp công trình xanh, ví dụ như là chúng ta áp dụng cái kính low E này, hoặc là những cái hệ thống đèn LED điều hòa có cái COP, cái số COP cao chẳng hạn đấy, thì những cái đấy thì nó sẽ được bóc tách thành một cái chi phí liên quan đến cái phần dự toán xây dựng. Thì cái này khi mà chúng ta đưa giải pháp thì chúng ta có thể tính toán được, tức là bên thiết kế rồi là bên dự toán, nhà thầu có thể tính toán được cái chi phí phát sinh thêm so với cả những cái giải pháp chúng ta dự kiến làm hoặc là đã hay áp dụng trước đây chẳng hạn đấy. Thế còn cái chi phí thứ ba thì nó sẽ liên quan đến chi phí tư vấn. Thì bởi vì công trình xanh hoặc là những cái công trình tiết kiệm năng lượng nó là những cái vấn đề mới, thì thường là sẽ cần có những cái chuyên gia để tư vấn cái việc đó, thì nó sẽ liên quan đến cái chi phí để trả cho cái người tư vấn để làm cái công việc này. Đấy, thế thì đấy là những cái chi phí mà nó sẽ liên quan đến cái việc công trình xanh cũng như là các cái giải pháp về hiệu quả năng lượng.
Cảm ơn anh Kiên. Có một câu hỏi nữa thì chắc là cũng sẽ phải nhờ anh Kiên trả lời. Các cái thông tin xuất ra từ Archicad thì chiếm được khoảng bao nhiêu % nội dung công việc để có thể làm được cái chứng nhận xanh?
Thực ra thì mọi người cũng nên hiểu nó tách bạch một chút, tức là cái nội dung hôm nay thì nó tập trung vào cái vấn đề là mô phỏng năng lượng, tức là chúng ta có thể tính toán và đánh giá được cái hiệu quả năng lượng đối với công trình thiết kế, và cũng có thể so sánh với cả mô hình baseline như anh Sendo đã trình bày, tức là cái mô hình ví dụ chúng ta có hai phương án khác nhau chẳng hạn, thì chúng ta có thể so sánh hai cái mô hình đấy để xem là mô hình nào hiệu quả hơn về mặt vận hành, hoặc là chúng ta có thể so sánh cái mô hình thiết kế của chúng ta với cả một cái mô hình theo các cái quy chuẩn tiêu chuẩn hiện hành, thì đấy là cái mô hình baseline. Thế thì đối với cả công trình xanh ấy thì nói chung thì các cái chứng nhận hiện nay, ví dụ như là LEED hay là Lotus chẳng hạn, thì cái đóng góp của cái phần về cái mục năng lượng vào trong cái tổng thể của công trình xanh, tức là thường thì chúng ta sẽ đánh giá dựa trên số điểm, thì là thường cái đóng góp của phần năng lượng thì nó sẽ chiếm cỡ khoảng 30% cái tổng số điểm của cái chứng nhận công trình xanh đấy, và đây nó là cái hạng mục mà có thể coi là quan trọng nhất trong các cái nhóm tiêu chí liên quan đến công trình xanh.
Cảm ơn anh Kiên ạ. Có một câu hỏi là cho mình hỏi ứng dụng thực tế ở công ty tư vấn thiết kế ở Việt Nam. Câu hỏi này thì khá là khó hiểu, vì nó cũng không được đầy đủ lắm. Mình sẽ hiểu nó theo cái hướng là như thế này, là ứng dụng thực tế của cái công cụ mà chúng ta đã bàn đến ở đây trong cái buổi webinar ngày hôm nay ở trong công ty tư vấn thiết kế ở Việt Nam. Thì mình cũng xin phép cái này mình cũng trả lời luôn cho đỡ mất thời gian, vì là anh Kiên cũng vừa mới trả lời cho tất cả mọi người cùng nghe. Thì cái công cụ ngày hôm nay chúng ta bàn ở đây là nó liên quan trực tiếp đến phần là tính toán mô phỏng năng lượng. Thì như anh Kiên vừa trả lời thì cái phần đấy là một trong những cái công việc của công ty tư vấn thiết kế công trình xanh ở Việt Nam, và cái khối lượng công việc mà cái ví dụ như cái công cụ Eco Designer Star ngày hôm nay chúng ta bàn của Archicad ấy, thì nó sẽ chiếm khoảng 30% cái khối lượng công việc cho một công ty tư vấn thiết kế cho công trình xanh. 70% còn lại sẽ là các công việc khác ở công ty tư vấn thiết kế liên quan đến vấn đề xin được để đạt được cái chứng nhận công trình xanh ở Việt Nam. Okay, Sendo, there is a couple of questions in the chat of this Zoom. I think one question is in English, so probably I just read it for you. Is it possible to share the Archicad 3D model with other BIM platforms such as Revit? And am I able to make use of this model for further environmental analysis with Grasshopper, Rhino? I think the first part is already answered.
Yes, but let's answer again, because it's always a good thing. So with in case of Archicad, we promote the open BIM concept, which involves the export to IFC and import of IFC. So basically, it's not just with Revit, but with all kinds of BIM tools. And the other way around, it should be the same, that you exchange information through IFC. In Archicad, we also have direct Revit export and direct Revit import. However, that's not that's just a reference model. So you will have edit in place elements. It's not a model that you continue working on. It's just for referencing. But in proper model exchange should be with IFC for model referencing as well. The second part, that's an interesting one, and I would probably reverse the workflow because with those analytical tools for Grasshopper, I guess what you mean, the ladybug, the dragonfly, honeybee, these ones. I would go the other way around and probably use them in the early phases when you're dealing more with messing models, because that's where you can have more effect on the changes, right? So here in Archicad, what you see is already something that that is beyond the sketching phase, a little bit beyond that. So if you really want to do those analytical things outside of Archicad, then I would do them in the early phase. And the reason why I'm saying this also is because we have a live connection between Grasshopper and Archicad. So if you do the analytical, the analysis in the early phases in Grasshopper with those tools, and then you can generate the design in Grasshopper with actual elements, then we can convert that directly into an Archicad BIM model. So there we have a generative design. And basically that is the detailed model. And with the detailed model, then you can do an actual energy performance review in Eco-Designer. So I would go the other way around if it goes for the workflow, because otherwise the only way to transfer, so you cannot really have a way of transferring a fully detailed model to Rhino and evaluate it further. I mean, you can probably still do, but then it's kind of like a baked version of the model. So that would be limited. So I would reverse the workflow in that case.
Okay, thank you, Sandor. There is a couple questions. Probably I will answer in Vietnamese to make it quick. Quy trình BIM đòi hỏi một đội ngũ team BIM với đầy đủ kiến trúc sư và kỹ sư chuyên ngành MVP phối hợp với nhau làm việc trong một mô hình online hoặc share mạng LAN để đạt kết quả tốt nhất. Câu hỏi này của bạn Emily. Câu hỏi này thì rất là xác đáng và chính xác là để đạt được một cái kết quả tốt thì cần phải có một cái đội ngũ tương đối là đầy đủ mọi người có thể xây dựng các cái mô hình BIM gồm có các kiến trúc sư và các cái kỹ sư chuyên ngành MEP phối hợp với nhau để xây dựng ở cái mô hình BIM trước. Thì như trong cái quá trình trao đổi ngày hôm nay thì anh Sandor cũng đã giới thiệu là cái khởi đầu của tất cả các mô hình tính toán bắt buộc sẽ phải xây dựng một cái mô hình của cái công trình kiến trúc đấy. Thì khi xây dựng cái công trình kiến trúc đấy thì không phải nhất thiết là chỉ dành riêng cho phần mô phỏng năng lượng mà sẽ có thể làm được rất là nhiều các việc khác, tuân thủ theo các cái quy trình làm việc của BIM. Tuy nhiên khi mà xây dựng được một cái mô hình đầy đủ như vậy xong với cái sự tham gia của kiến trúc sư và các kỹ sư chuyên ngành MEP thì cái mô hình đấy hoàn toàn có thể sử dụng để mà có thể phục vụ cho cái quy trình BIM có kết quả tốt nhất. Câu hỏi khác cũng tương đối là không liên quan đến cái buổi webinar hôm nay, nhưng mà một câu hỏi mà rất là phổ biến đấy là Archicad có phải là một phần mềm phổ biến trên thế giới tương tự như Revit hay không? Xin phép được trả lời câu hỏi này rất là nhanh thôi, bởi vì Archicad và Revit đều là những cái công cụ BIM tool hàng đầu trên thế giới. Mỗi cái đều có những điểm mạnh và điểm yếu riêng. Ví dụ như là đơn giản như là về phần chi phí sử dụng Revit chẳng hạn thì mỗi một năm sẽ phải trả tiền bản quyền một lần. Còn Archicad sau khi mua thì có thể sử dụng vĩnh viễn, thì đấy cũng là một cái điểm mạnh và cũng là một cái điểm yếu của các phần mềm. So sánh cái này nếu mà đặt so sánh một cách trực tiếp như thế thì cũng tương đối khó. Nó cũng giống như chúng ta so sánh giữa Windows với cả macOS. hai cái hệ điều hành rất là nổi tiếng trên thế giới, rất khó để mà có thể so sánh được trực tiếp với nhau. Thì xin phép được trả lời câu hỏi đấy như vậy. Chắc là cái buổi hội thảo ngày hôm nay của chúng ta cũng đã kéo dài tương đối là dài so với cái thời gian cho phép của bên chỗ anh Bình. Rất là cảm ơn mọi người. Thì xin phép chỉ trong mấy phút cuối cùng đây thì xin phép được giới thiệu nốt một cái ý hơi ngoài cái nội dung ngày hôm nay. Vì là cái buổi này thì chắc là chúng ta cũng sẽ kết thúc thôi, vì là cũng đã 12 giờ kém 5 rồi, và diễn giả Sandor của chúng ta đã phải nói liên tục cũng gần 2 tiếng, rất là mệt. Thì VNco, công ty Grasshopper và chỗ ban chỉ đạo BIM quốc gia thì đã có ký một cái hợp tác về việc thúc đẩy cho cái sự phát triển BIM ở Việt Nam. Và một trong những nhiệm vụ của cái ký kết đấy là cung cấp các cái nội dung thông tin liên quan đến BIM hay là các cái khóa đào tạo. Thì ngày hôm nay phía xin phép được giới thiệu nốt một cái thông tin, đấy là cái trong tương lai rất là gần, có thể là trong tháng sau, thì phía VNco và phía ban chỉ đạo BIM quốc gia và công ty Grasshopper sẽ cố gắng tổ chức một cái chương trình 3 cái buổi mini course liên tục về giới thiệu về BIM, chứ không liên quan trực tiếp đến phần mềm nào cả. Ở đây module thứ nhất sẽ giới thiệu về việc triển khai BIM ở trong một công ty, làm thế nào để quản lý được BIM, làm thế nào ứng dụng BIM vào trong các công việc hàng ngày. Module thứ hai là module liên quan đến tạo lập template cho dự án. Cái thời gian và cái công sức đổ vào giai đoạn đầu của bất kỳ dự án nào cũng rất là mất thời gian nếu mà không có sử dụng các template, và đôi khi ở trong các công ty thì cái quy trình làm việc của chúng ta nó có những cái phần mà chúng ta có thể copy và sử dụng lại được. Thế nên việc tạo ra các cái bản mẫu template ở trong giai đoạn đầu của quá trình dự án sẽ giúp cho chúng ta thực hiện nhiệm vụ nhanh hơn và tốt hơn. Và cái cuối cùng, một cái module ở cái module thứ 3 của cái chương trình này sẽ là cái việc phối hợp công việc trong một cái dự án BIM, giúp cho một cái điều phối viên dự án có thể thực hiện các cái công việc liên quan theo một cái trình tự nhất định. Vì cái khóa này sẽ do anh Sandor đứng ra là một diễn giả chính, nên anh Sandor chắc có thể sẽ phải sử dụng cái công cụ, cái phần mềm Archicad để demo một số cái tính năng ở trong các cái module này. Về chi tiết của từng module thì mọi người có thể liên hệ với mình ở trên qua cái website của công ty vnco.vn để mà có thể cập nhật thêm các cái thông tin về các cái module này. Chương trình này cũng đã được lên kế hoạch với ban chỉ đạo BIM quốc gia và đang có được cái sự ủng hộ của rất là nhiều cá nhân và các cái đơn vị ở trong xã hội, vì đây đang là một trong những cái yếu tố vẫn còn khá là mới ở môi trường ở nước ta, khi mà tạo ra một số cái rào cản nhất định trong cái việc ứng dụng BIM vào trong ngành thiết kế và xây dựng. Thì xin phép là hết cái phần trình bày chia sẻ của mình. Thì cái thông tin này sẽ tiếp tục sẽ được share ở trên website chính thức của ban chỉ đạo BIM quốc gia thông qua chỗ anh Bình và các bạn ban nội phối ngày hôm nay. Vâng, thế thì cũng chương trình ngày hôm nay chắc là cũng đến đây là hết. Vẫn còn một số câu hỏi của các anh các chị, thì mình sẽ cố gắng ghi nhận các câu hỏi này, dịch sang tiếng Anh và chuyển cho anh Sandor để anh có thể trả lời mọi người thông qua email hoặc là thông qua một cách thức nào đấy mà anh chị cảm thấy là phù hợp. Vì là cái thời gian hôm nay cũng đến đây cũng đã là hết, nên là xin phép và rất là xin lỗi vì là vẫn còn một số câu hỏi của anh chị là vẫn chưa được trả lời một cách đầy đủ. Vâng. Ok, chắc nhờ anh Bình kết thúc nốt.
Vâng, cảm ơn anh Minh. Thì chắc chắn là sự kiện hôm nay rất là hay và hấp dẫn, nên là mọi người cũng có nhiều câu hỏi. Thì nếu mà còn câu hỏi nào mà chưa được trả lời thì chắc là sau đó sẽ nhờ anh Minh hoặc các bạn gửi để lại thông tin trên Facebook, gửi qua email cho ban tổ chức để sẽ tập hợp và nhờ anh Minh gửi đến diễn giả Sandor. So Sandor, thank you so much for your presentation and all the answer. And we hope to see you soon in the BIM management mini course. Thank you.
Thank you very much for the opportunity, and thanks everyone for attending. Take care.
Thank you, Sandro. Thank you very much for spending 2 hours with us today. Your presentation is absolutely informative as normal. I have a few people saying that thank you, Sandro, thanks all. And this module is very interesting, and they are looking forward to the next one, as I just introduced about the mini course that we're gonna do in the near future.
Wonderful. Okay, see everyone there.
Okay, so cảm ơn tất cả mọi người, cảm ơn đã dành thời gian tham gia buổi webinar ngày hôm nay. Cảm ơn anh Bình và tất cả các bạn ở bên ban chỉ đạo BIM quốc gia đã dành thời gian tổ chức cái buổi này. Thay mặt cho công ty VN-Co xin gửi lời chào tất cả mọi người và chúc mọi người trong giai đoạn khó khăn này của xã hội, tất cả mọi người giữ gìn sức khỏe, an toàn cho chính bản thân và xã hội là trên hết. Xin chào mọi người.